Hello, in this video I will show you how to calculate online either powder, X-rays or neutron diffraction patterns from uploaded crystal structure files. And for that we will use a newly developed tool which is called XRD created by Implant team, and you can get to it if you write this name.com. The uploaded structure files are supported in various formats. You can put here a CIF or POSCAR from WASP or LMP from LAMPS. And if you don't have the structure files, you can also search in implemented search interface for three databases and directly retrieve the structures. So you can search in Materials Project, AFlow, or Crystallographic Open Database. This XRD Licious application currently includes 4 modules. So one of them is this calculator for powder diffraction patterns. Then there is a module to visualize the uploaded structure, and it also supports some basic modifications of them. Another module is to calculate pair radial distribution function, and then there is an interactive data plot module which allows you to upload here any 2D column files and interactively plot them here. And if you upload XRD data, you can also convert them from different wavelengths or into D-spacing or Q spacing representations. And also you can you can switch or convert the data from fixed divergence slits to automatic divergence slits and vice versa. Okay, so let's illustrate it already on an example, and let's say that I want to calculate a powder diffraction pattern for beta titanium and alpha titanium. I already prepared beta titanium CIF file here, so I will select it. And because I have this structure modification tool on, I can see that the structure that I uploaded is the correct one, and if I need, I can change the cell representation from this conventional cell to primitive cell representation, and I can download also the structure in different formats. So I uploaded CIF and I can obtain it in WASP format or in LAMPS format or in XYZ format. So basically you can also use this as a certain conversion tool between different file formats, which can be useful if you, for example, want to do some DFT simulations in WASP on your CIF file. So you can upload CIF file and download it in WASP format. And I also have here the alpha titanium, but to illustrate how this search in databases works, let's find it here. So I'm looking for titanium, and let's search in all 3 databases. So now it began the search, and it materials project in found 10 structures which has this element. In AFlow there's 27, and in COD there are 9 structures. And I can now add or browse in the found structures. So this is what was found in materials project. You can see the lattice parameters, number of atoms, space group, structure type, or density, and there is the link to the structure if you need to obtain more information about it. And you can also directly download its CIF file and add it to the calculator. So let's add from COD database the alpha titanium, and for example let's add this one, add selected structure, and it was added here, and you can already see it in the visualization. And I can switch back to beta titanium. Okay, so now I have both files, and for the illustration I can just modify. Currently what is supported is to modify the element type and the occupancy. So let's say I want to change this titanium to iron, for instance, and also I can modify its occupancy like this, so that there will be 50% of iron vacancies. And then I can modify the lattice parameters so it follows the symmetry. Now if I change this A lattice parameter, it will be uploaded to B and C. And let's just, for illustration, do it like this. Or I can override this symmetry constraints and change any lattice parameter I want. And to save this lattice parameters change, I need to apply it with this button. Okay, you can see the lattice parameters are now different. And to save this modified structure, I need to do it with button here, and I can change its name. So let's call it, for instance, like this, and save it. Add it to the calculator, and you can see, yeah, it's saved. It's this one, and I can also now download its corresponding different formats. Okay, and now I can calculate their diffraction patterns. So let's just calculate it directly with this predetermined settings, and you can already see it here. And this is interactive graph, so I can zoom or hover over the peaks and see like their corresponding HKL indices and from which phase it is. And now I can modify the settings, so I can change this peak representation into Gaussian representation, or I can have an absolute intensity scale. Then I can change if I want to have the XRD or neutrons. Okay, let's put it back. The wavelength, I can select different one, or if I need custom, I can just modify this value. The x-axis matrix, so instead of 2 theta I can have it already in for instance q vector. You can see it was modified. I can also apply the bipolar temperature factors for each element separately in each structure file. So let's not do it now, and let's just put it back to 2 theta. And then I have here the list of all peaks at the corresponding position and intensity with their HKL indices for each phase, or only for each phase, like the highest here 5 highest intensity peaks. This number I can modify by this parameter. So for instance, if I want only 2 highest intensity peaks, I put it here 2, and they are here now. Okay, and then there is interactive table with all the phases and where I can sort. So I can sort, for instance, by intensity, or by HKL indices, by phase, or this x-axis matrix. And if I need to download these like continuous data, I can do it with this button, which will prepare the data, and then I can download them. Okay, And if I would have my experimental data, I can also upload them here. So let's just illustrate it, and let's put it to normalized scale. So now you can see that I uploaded certain experimental data. And just to illustrate you, I know this is titanium with 20% of niobium. So let's search for this structure and just COD database. Okay, now it's finished. I know already it's this phase, so I will select it, add to the calculator, and it looks like this. I can remove these files that I don't need anymore, the previous files. Okay, so let's just keep this structure here, and now I can see how it fits to my pattern. So you can see it fits all the peaks except there is some lattice parameters shift, and because I already did Rietveld refinement before, I know what are the correct lattice parameters. So if I can change it, like create here the correct structure which describes this XRD pattern, and for I know that the lattice parameter A is this, and the lattice parameter B is this one, and the C parameter is on this. So I will apply these changes and save this structure as this. And now let's see how this modified one fits my peaks. So you can see it fits them exactly. I can hide this face. If I need, I can make this graph full screen. Okay, so that is all to this online calculator tool, which will allow you to compute powder either X-rays or neutron diffraction patterns on your structure files. And I hope this tool will be useful for your application, and thank you for your attention.